Nyepagi demunyu skula Nyepamne ne kudlukula Nyepangi ragala gena Nyepamne ne kudlukula Ibuloke numoto ni beti sola Ibuloke ni beto
Mingi Congo
Lamin
na
Lamin te jibe norin te nyame Lamin
kabana wulokono
wulokono nyinte mo Lamin
pabilenki
muna ngata afongole
haina
ngata ngoto le fabrama
mingi baba nyola
ngoto le fabrama
namu jumara kan kuma ni ten
fabrama
jumara mu
ndele bare muso
lunda mana
famo kata
jamani bere
allendo ko
jamani
bari ngoto mon kontande
bari jamani fana na mudu kontan
ngoto minaka ngala min je fon fili tala la min jibe nori nyaala
lamin ida siran sama ne benki yala so tol sayni no ko ngol ko momo
ngoto
nam
iterinte yalo ne lamin hakkilo diata bake karam ngoto anu santen ministry ko di ngole sisu
si bitun
bagona de
ala ni ko kede namo balo
ala na ko na karta bulo be dam ala nije
ngoto
nam
ngoto mon kontan fere
jamani mu nekata
ite ka lamin ki wulo ko no nyinta mon ko do fete malo lamin nyanta sila la be la moy kala karango
jamani karam be soron ne ko fasi ta wulo ko
baba karam wol ma ko ni ko karam wol soron da man ko comme holiday lem ngoto dindi wo nyanta sila la ala karango la moy yamen kamen fue man kontan andamande
alla nyin kombo kura adanda la kombo ndo la jankara mol soron do kamen kura ma ra do kombo e don do fana na kara mol soron je kara mol soron lamin ada lo nyino la amata fa na so hon ala mu nekela
lamin ite fede malon ko lesinol de ke kar radio to
nga fine
e ko yana mo lamin
nga fine
ya mo na fonye
bi tabin mina kan tambita nteri maning fatu tambite la sugal ala dinol bebe siri be la moy ka
faru dan so amban tambira jere ni subala la ngaje dinol be jet talanta nen kili waro e be serin jelet
sa lamin farante ku kili wo ke no la ba lamin bi ka wulo ko no nyinta mo alami
amandara fenela
ite dine ko ni man si yakari la sino la moy radio to e balon na
mo ne ka ke afende ma nyaara ni alon
telentel jikot
afende ma mo be ke
ite telentel be jikritel ni man karam be ku kele yaaje nata karana mbasa mala ya itarije
bar nyaarande ko mo courant ho findira ko ide na radio ni sonka bay ko lamin ma nyaata la ko aru karam mo be so da
ko to wole nati bayo ngalle ni lamin kuntala kombo courant e ka fa me kombo courant asototal wala kinay ko e sisu kono bari ni ko e sisu kono be karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto da bongo bar radio be bulen koto batiri sanga ay si ay alamo
sa do kala
ko ta o bulaji
ado kala nyaadi
kamun ke nyaadi
radio abo la mo la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karande
ila subject ro baby jele baby jele
wala nanga chocho moy fa dan so wala ko metan bi kadum bu ko de kala
ma asototal de
la min mala be kala wala de
bari laftalal ideal on ko inde every year second wala fourth
mona ni ko di ha ko de ko folle sinila ba ndele sinilo ne ba
mba say mba foke yon koto wole fango yen wulindi yalo famo keta bat ñu fanam bulata ko ko do me yen nati jambi la min nyanta karana ndel beji ko be nyine ka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dindi ngoy si ayala le sino la moy radio
wora ka munda kara mo man soro la min nyanta kara si so na
radio la sino le ayala le sino
dal ko korno ko smalo
kilar ya
mo be ngala ko mo sa mi do ni ko no kara
mengi bruzo
am no ko do la da ba rosa no radio ba no bari woro radio ni abe jele ba ngam radio man dembe buljan dala nyara nyar woro ko fendi mo la tan tayra ba rosa
bara ke ku folo ajibe nori nya labi tamete
mengi mun na re
teku
bari ko do famo ke
imagine nani nyambol si zol le ke je kisigi man si zol no le kabun ka nyoma bari nyambu kino ni manya na kafindi ni nambe ko zol la ga
ngale limbeta de be nyambo do dilanna
nyara ni ko ridin fennat nyara nata
bari famo ke da
nata bun kono tabi bun kono nyara ngando ko mele ko ke baru nganda ni pelo la ndija
iyo awata la
bun kono bismillah bi sudi ara
pendulala yefungo tanka sina lulu tanka koro ta koro Sole ngambulo luku. With whatever we do. Jioni safu nola. With whatever we do. Hale yidemu nyuskula. Nyepamne nekudlukula. Nyepangi ragala gena. Nyepamne nekudlukula. Ibuloke numoto nibeti sola. Ibuloke ndato nibetoto.
Bengi Congo.
Lamin.
Na?
Ike jibe norin tamin.
Kabana wulo kono.
Wulo kono nyinta mo lamin.
Pabilenki.
Muna ngata afongole.
Haina.
Ngata. Ngoto le. Fabrama.
Bengi. Baba nyola.
Ngoto le Fabrama.
Namu jumala kan kuma diten.
Fabrama.
Jumala mu.
Ndele bare muso.
Nunda mana.
Famo kata.
Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na mudu wa kontan.
Ngoto minaka ngala min je fon filitala. Lamin jibe nori nyala.
Lamin ila siran sama ne benki. Yala so tol sayni no ko ngol ko momo.
Ngoto.
Nam.
Itedinte yalo ne lamin hakilo diata bake karamngoto. Anu santeng ministry ko di ngole si suwo ko amanke ko do holi
si bitun.
Bagona ringa.
Ala ni ko kede namo balo
ala ni na ko na karta bulo be damla ala ni je.
Ngoto.
Nam.
Ngoto mon kontan fere.
Jamani mu ne keda.
Ite ka lamin ki wulo ko no nyintay mon ko do fete malo lamin nyanta sila la be la moy kala karango.
Jamani karamol be soron ne ko fasita wulo ko ko.
Karamol ma ko ni ko karamol soron da amanke ko holiday lem. Ngoto. Dini wonyanta sila la ala karango la mo yamen kaben fue man kontan anda mande
alla min kombo courant adan dal kombo len do la jan karamol le soron do kamen courant ma dal lo kombo e don do fana karamol soron je karamol soron la min adara lo ni no la aman tara fe na sokon ala mu nekela
am lamin ite fete malon ko lesino de ke kar radio to
nga fine
e ko yaadi mo lamin ya mu na fonye
kabin bina kan tambita nteri maning Fatu. Tambide la sukala ala dinngol bebe siri be la moyka.
Faru danso am fana tambida jere ni subala la ngaje dinngol be jet talanta nin kili waro. E be seri jelet. Sa
lamin farante ku kili wo ke no la ba lamin bita ka wulo ko no nyinta mo alamin.
Aman dara fennala.
Ite dine ko di man siri kari la sino la moy radio to balon na.
Mo ne ka ke afende ba nyaara ni alon.
Talentel jikot.
Afende ba mo de be ke.
Ite balentel be cikritel. Ni man karambe ku kele. Yaaje nata karana mbasa malaya ay tarije.
Par ñarande kombo courant ho findira kombo ide na raje den sonka bay ko lamin manya tala wulo ko karam mo be so da fa ne membe
ko to wole nati bayo ngalle ni lamin kuntala kombo courant e ka fa me kombo courant asototal wala kinay ko e si suwo kono bari ni ko e si suwo kono be karangol di ke la radio lin telel to hani tele masoto to nyaay man tele soto da bongo bar radio be bulen ko to batiri sanga ay si ay alamo
sa do kala
nyaadi ko ta o bulaji
ado kala nyaadi
kamun ke nyaadi
radio abe wala mo la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karande
ila subjectol baby jele baby jele
wala nan ka coco moy fa dan so wala ngom metambi kana ngadi ni wolde be ikadum bungo ko kala maro mo
asototal de
la min mala ka wala de
bari laftalal ideal on ko inde every year second wala fourth
mona ni ko di ha ko nde ko folle sinila ba ndele sinilo ne ba
mbasa mba foke en koto wala fango yen wulindi yalo famo keta bat ñu fana bulata ko ko me yen nati jambi la min nyanta karana ndel be jiko be nyineka ya bulay kara wulo kana ta kilar ya bambalo yo be bulaje en koto dinni ngoy si ayala le sino la moy radio
wara ka munda kara mo man soro la min nyanta kara si so na regular
la sila le ayala le sino
dal ko korno ko smalo
kilar ya
be bin ko mo mo say mi do ni ko kara
nengi bruzo
am ndelo ko la da ba rosa no radio ba no bari woro radio ni abe jele ba do ngamro dembe buljan ala nyara nyara woro ko fendi mo la tan tayra ba rosa
bara te ku folo ajibe nori nya labi tamete ku
teku
bari ko do famo ke
ja image nani nyambol si zol le ke je kisgi man si zol no le kabun ka nyoma bari nyambu kino ni manya na ka fendi ni nambe ko do la ga ni nambe ko do la ga
ngalle limbeta de be nyambo do dilanna
nyara ni ko rin fennat nyara nata
bari famo ke da
nata bungono tabi bungono nyara ngando go fele ko ke bar nganda ni pelo la ndija
iyo a
la bungono bismillah bisu diara
pendulala ye fongo tanka sina do tanka koro ta koro
if you have this alkene, which is propene, reacting with hydrogen gas in the presence of nickel catalyst, the hydrogen is a molecule, and this hydrogen molecule will undergo homolytic fission, where it will form two radicals, two hydrogen radicals, and each of these hydrogen atoms will add onto the carbon-carbon double bond. So what will happen is one hydrogen will add onto one of the carbons that bears the functional group, that is the double bond, and then the other hydrogen will add onto the adjacent carbon. So therefore, our product, okay, this carbon was having one hydrogen before. When one adds onto that, we'll have two hydrogens. And then this carbon was having two hydrogens, and an additional hydrogen will make it 3. So our product will be propene. Okay. So therefore, when alkenes undergo addition reaction, that is hydrogenation reaction, they produce an alkene. Another addition reaction is reaction with hydrogen halides. Which means what? The addition of where the X represent what? A halide. Okay. So here, what happens is a hydrogen and a halogen is added to the carbon-carbon double bond. Let's look at an example. We'll use the same molecule, that is propene. Sorry. That's propene. Reacting with, let's say, hydrogen chloride, which is a hydrogen halide, in the presence of a solvent, let's say ether. Okay. So the same or similar reaction will occur here. That is, this species here will undergo homolytic fission, where we'll have two radicals. Yeah? One will be a hydrogen radical, and then the other one will be a chlorine radical. And each of these radicals will attack the carbon-carbon double bond. So here, since the molecule is not symmetric, we'll observe the law or the rules of Markovnikov, which states that the hydrogen will add onto the carbon that has more hydrogen atoms, and then the halogen will add onto the carbon that has less hydrogen atoms. Okay. So if you look at these two carbons, they are the carbons that bear what? The functional group. So this carbon here has only one hydrogen. The terminal carbon has two hydrogens. So therefore, the terminal carbon has more hydrogens than the adjacent carbon. So therefore, the chlorine will add onto the carbon that has what? The less number of hydrogens. And then the hydrogen will add onto the terminal carbon because that one has more hydrogen. So our product will look like okay. So we'll have a product called chloropropane, okay. Or you might call it 1-chloropropane. Another addition reaction that we'll look at here is addition of bromine water. Okay. Bromine water is a chemical which can react with alkenes. And we can use this process as what? A chemical test. That is to test for the presence of alkenes. Alkenes generally will decolorize bromine water, which is yellow in color. Okay. For example, this is ethene. When ethene reacts with bromine water, we'll have a product that looks like okay. So we'll have 2 bromo 2-bromoethanol. So 2-bromoethanol will be our product when ethene reacts with bromine water. So the bromine water is yellow in color, and this color will fade out. Yeah, like I mentioned earlier, this could be used as what? A chemical test for the presence of what? Alkenes. Another reactions of alkenes is addition of halogens. Which can also be referred as what? Halogenation process. Okay. Alkenes will react with halogens in the presence of what? A solvent like tetrachloromethane to produce what? A vicinal halide. That is, for example, if we have propene as our starting material, reacting with, let's say for example, chlorine, which is a halogen, dissolved in tetrachloromethane. The chlorine will undergo homolytic reaction where one of the chlorine radicals will add onto one carbon, the other will add onto the other. We have what we call a dihalide. That is two halides on adjacent carbons. So our product will be named as 1,2-dichloropropane. So that will also add in the same manner. That is, they'll end up forming a vicinal dihalide. Another reactions of alkenes that we'll look at is hydration of alkenes. Hydration has to do with what? The addition of water. Okay. When water is added to an alkene, like for example, if you have ethene reacting with water in the presence of sulfuric acid at room temperature, this will produce an alcohol. This method could be used in the preparation of alcohols. That is, ethanol could be produced from this reaction. So we have a hydrogen and a hydroxide added to the carbon-carbon double bond. So a hydrogen is one of the carbons, and then the hydroxide is added to another carbon. So suppose the molecule is asymmetric. This one is a symmetric molecule. Let's say, for example, you have propene. This molecule is asymmetric. When this reacts with water, in the presence of sulfuric acid, okay. So hydrogen will add onto, so this is going to follow Markovnikov's rule, where we'll add hydrogen to the carbon that has more hydrogens, and then the hydroxide ion will be added to the carbon that has less hydrogen. So our product will look like this. So this produces what? A secondary alcohol. So this alcohol could be named as 2-propanol. So if the molecule is symmetric, it does not matter where you add the hydroxyl ions or where you add the hydrogen. But if the molecule is asymmetric, there will be regioselectivity in the addition, and that will follow the Markovnikov's rule. Another reaction of alkenes is polymerization reaction, which is a reaction which involves what? The production of polymers. Okay? Polymers are larger molecules which are made from smaller units or smaller molecules that are referred as monomers. So in polymerization, let's say for example, we have ethene in the presence of oxygen and heat will undergo a process called polymerization. So N here means many units of what? The alkene. And the alkene here, for example, the alkene we're looking at as our example is what? Ethene. So if you have many units of ethene undergoing polymerization, you need what? Oxygen, and then heat, and then high temperature. And this will produce a polymer that will look like that. So you'll have a polymer that looks like that. So this is going to be a very large molecule. Okay. And then finally, we look at addition reaction of oxidizing agents. Addition of oxidizing agents like potassium permanganate, potassium dichromate. So when oxidizing agents react with alkenes, they produce a vicinal diol. Okay? That is two OH groups on adjacent carbons. Let's take, for example, if you have propene as our starting material, reacting with potassium permanganate in acidic condition. Okay. In acidic condition. This will form a product that is referred as a diol. So you have two alcohol functional groups on adjacent carbons. Okay? So this is what is going to happen when strong oxidizing agents like what? Potassium permanganate or potassium dichromates reacts with an alkene. Our product will always be a vicinal diol. So next we talk about, or we look at the laboratory detection of what? Alkenes. How do we detect alkenes in the lab? One method used in detecting alkenes in the lab is using bromine water. So alkenes will always decolorize yellow bromine water. So this can be used as a chemical test to differentiate an alkene from an alkane. Alkanes, when they react with yellow bromine water, there will be no color changes. Okay? But if they react with an alkene, the yellow color will decolorize. It is going to fade out. Okay? And another chemical test we can use is alkenes will decolorize purple acidified manganate. Potassium permanganate is purple in color. So when acidified, if you react it with an alkene, the purple color will fade out. Okay? So this could be used as a chemical test for the presence of alkenes and also to differentiate alkenes from from an alkane. Alkanes, when alkane reacts with what? Purple potassium permanganate and acidified, there will be no color changes. And then finally, we can use potassium dichromate, which when acidified is orange in color. If you do not acidify it, it's yellow in color. But if you acidify it, it becomes orange in color. The color changes to green. So it could also be used as a chemical test for the presence of alkenes and also to differentiate alkenes from alkanes. Because alkanes with potassium dichromate, there will be no color changes. Okay. Next, we talk about the uses of alkanes. Okay. One, alkanes are used to fasten the ripening of fruits. Right? Like ethene is a hormone found in plants, or in fruits rather, and it is used in fastening the ripening of fruits. Okay. And we also use alkenes to synthesize polymers, the process of what? Polymerization. Okay. Polymers are very important chemicals or materials we use in our daily lives. Okay. And we also use alkenes to produce alkanols, like we've looked at one of those reactions. And also alkenes can be used to produce detergents. Okay. Detergents are cleaning agents. And then we can use alkenes to produce 1,2-ethane diol for use in automobile radiators. Let's try these sample questions together. Question 1 reads, write a balanced chemical equation for the reaction of chlorine with, so the first substance is ethane. So you have to write a balanced chemical equation for the reaction of chlorine with this species. So the first one is what? Ethane. This substance here is made up of carbon-carbon single bonds. So it is referred as an alkene. Okay. So when alkenes react with halogens, that's their general reaction, they will produce a haloalkene and then a hydrogen halide. Okay. So now let's look at this equation. That would be a general reaction. Now let's look at this reaction between what? An alkene, which is ethane, and then a halogen, which is chlorine. In the presence of UV light, okay, this will undergo substitution reaction, where the chlorine will be substituting a hydrogen from the alkene. So a hydrogen will be replaced by a chlorine. This species here, that is chlorine, will undergo homolytic fission. And when that happens, it will produce two radicals. So one of the radicals will displace hydrogen. It's going to substitute hydrogen from the alkene. And then the other goes out with hydrogen to produce an inorganic compound. So therefore, our product will look like Cl plus HCl. And this type of reaction is referred as a substitution reaction. So the second question is the reaction between ethene and chlorine. Reaction between ethene and chlorine. So this is an unsaturated hydrocarbon, okay, because of the presence of what? The double bond. So therefore, this will not undergo substitution reaction. Instead, it will undergo addition reaction. So the chlorine will add onto the carbon-carbon multiple bond. And as a result, we will have only one product. That is CH2Cl, CH2Cl. So this is an addition product because the species are added onto the carbon-carbon double bond. So this is one way of what? Differentiating addition products and then substitution products. For substitution, you have more than one product. But in addition, you have only one product formed. The next question is, State the type of reaction exhibited in each of the reactions in A above. I guess we have already answered that. The first is a substitution reaction. Why? Because a hydrogen is being replaced by chlorine. And then the second one is an addition reaction, because chlorine is added to the carbon-carbon double bond. And the second question is, give one chemical test to distinguish ethane and ethene. Okay? Ethane, we said, is an alkene because it's made up of what? Carbon-carbon single bonds. And how do you know that is an alkene? Is the suffix ane. All alkanes ends with ane. And then ethene, the ene tells you it is the suffix for what? Alkenes. So to differentiate an alkene from an alkene, we can use various methods. We can use different chemicals. One, we can use bromine water, which is yellow in color, which when reacts with an alkene, like ethane, there will be no color change observed. But when it reacts with an alkene like ethene, there will be color change observed. So the color change is going to be, the yellow color will fade out. Okay? And if you use another reagent like potassium permanganate, which when acidified is purple in color, when it reacts with an alkene, the color remains. So when ethane, which is an alkene, reacts with potassium permanganate, the color is going to remain. But when ethene reacts with acidified potassium permanganate, the purple color will be decolorized. The color will fade out. Okay? So we can use those chemical tests to distinguish between ethane and ethene. And then finally, you have to name the products that have been represented by letters in the following reactions. So the following reaction takes this order. We have ethanol, excess, so this is the reaction. Your starting material is ethanol, and it reacts with the reagent concentrated sulfuric acid, excess concentrated sulfuric acid, and A is produced. A also reacts with what? Bromine in CCl4, which is a solvent, to produce what? B. Okay. So let's look at what reaction will occur between ethanol and then concentrated sulfuric acid. Concentrated sulfuric acid is used as dehydrating agent. That means it is going to remove a water molecule. So a water molecule will be removed from ethanol. Let's look at the structure of ethanol. So when this molecule reacts with concentrated sulfuric acid, the sulfuric acid is going to remove a water molecule, wherein it removes what? The OH from the carbon that bears the OH, and then it removes a hydrogen from the adjacent carbon. So we'll have OH coming out with hydrogen from the adjacent carbon. So these two forms a water molecule. So therefore our product will be CH2. When one hydrogen is removed from here, we'll be left with two hydrogens and then a double bond. And then when you remove what? The OH, what remains is CH2. So we'll have CH2, double bond, CH2. So A is ethene. Okay. So A further reacts with bromine, which is a halogen, in the presence of what? CCl4 to produce B. So what happens here is this will undergo addition reaction. Okay. So the bromine is going to add onto the carbon-carbon double bond. And when that happens, our product B will look like so we'll have 1,2-dibromoethane. Okay. Okay, that brings us to the end of the lesson. Until we meet again, thank you. Bye for now.